Welcome back. Thank you for staying. I want to welcome you to group exhibit Hydrogen Fuel Cells at the HANNOVER MESSE 2012. It's the 18th time we're here. And this afternoon, early afternoon, we have a real treat for you. Please join me in welcoming Precision Combustion Inc. Right now, I'm going to welcome Anthony Anderson, who is Director of Marketing and Business Development. And we're going to be exploring together microlith fuel reformers, fuel processors, and catalytic oxidizers. So, a warm welcome to Anthony Anderson, please.
Wonderful, thank you.
And we're going to make some space for something special.
There we go.
Thank you. So, welcome, Anthony.
Thank you very much.
Let's start off by if you could maybe tell us a little bit about your company, who you are, what brings you here, all the way from Connecticut.
Oh, wonderful, yes. I'm with Precision Combustion of North Haven, Connecticut, USA, also known as PCI by its initials. And we're in the booth over my shoulder with the Connecticut group of companies, several companies over there, UTC Power, Dexmet, Valence, and ourselves. Proton Onsite is actually across from us. They're from Connecticut as well, and we have the state of Connecticut here representing us. PCI is a small business, privately owned. We've been around since 1986. Focused on the hydrogen and the syngas area, doing reforming and fuel processing since about 1999 or so. Developing the three basic technologies, CPO, steam reforming, and autothermal reforming, as well as catalytic oxidizers for fuel cell systems and a variety of applications.
Great, thank you. Can you tell us a little bit about the technology that you develop and commercialize right now, and the products you're commercializing?
Yes, absolutely. What we use is we have a patented and trademarked technology called Microlith. Think of it as a catalyzed mesh or screen type technology that we use for our, as a platform technology for all these applications and processes. And so the Microlith technology is something that we take and we design into reactors and systems, and we integrate those. And so we use them for solid oxide fuel cells. We use them for the PEM type fuel cells as well. We integrate the reactors and reformers and fuel processors together. We also have CPO, or catalytic partial oxidation, which is fuel and air reforming, and we use that for both syngas production and then also for what we call combustion augmentation, so converting fuel and using syngas in various engines, gas turbines, Stirling engines, and the like. And then we also have catalytic oxidizers that we use for a variety of applications, including for fuel cell systems, the anode gas oxidizers and start burners for such systems and the like. We've done a lot of research and development. Our company is primarily funded by research grants and contracts from the U.S. government, but some commercial contracts as well, working with partners and collaborators. And so one of the good things about working with PCI is our the fundamental research has already been funded by other parties, basically the U.S. federal government. And so we've taken the science into a technology. Now we're trying to take the technology into products. And our technologies typically enable other products to be better. And so that's one of the core things that we try to do, is find the right collaborators to work with, whether they're stack companies, fuel cell system companies, vehicle integration, system integration type companies, prime contractors, and the like. And so we're very successful with that in the U.S., and we've had some relationships, and of course working with the Army and the Navy and the Air Force and the like on the military side. And then most of our commercial relationships are confidential. There are a couple that we have worked with that are public, such as Ford and Ballard and companies like that.
So that's also a message to Hanover Fair, what you're looking also to achieve here, and we'll return to that in a moment. But let's just briefly look at the technology itself.
Sure.
I'd like to know, first of all, what Precision Combustion Inc.'s unique value proposition is. And perhaps we can look at this wonderful prototype that you have brought along.
Yes, the mesh technology that I mentioned, one of the things, the attributes that it has, is that it does not form boundary layers readily, whereas other type of catalytic substrates such as monoliths or meshes, pellets and the like typically have those type of attributes. So in these oxidation or partial oxidation type reactions like autothermal reforming and CPO type reforming, we're typically 10 times lighter, 20 times smaller, and have 30 times the transient response of other types of technologies. And so, for example, here's a prototype mock-up that I have with me. This would be about 5 kilowatts thermal. So if you put it into a solid oxide fuel cell stack, let's say maybe 1 to 2 kilowatts electrical. We've actually tested this technology with 3 different solid oxide fuel cell companies, including Adaptive Materials is one in the public domain, a very small soft C company in Michigan. But this is actually an integrated package. So at the top you'll have a fuel, air, and steam injector. We have an autothermal reformer in the center about the size, this big, size of a battery. And then around the periphery we have a steam generator in. So we put water in and take steam out and use that heat removal to cool off the reformate so that we can remove sulfur compounds, because we primarily do this for liquid fuels, a lot of transportation applications. And then we have a zinc oxide sulfur removal bed, which we basically size based on the maintenance cycle that you're looking for these various applications and the like. And so this technology is actually moving forward. It's a scalable technology. So we've actually scaled this up to 10 kilowatts electrical. We'll have 2 systems that a fuel cell company is integrating currently, and will be tested in a field test here in the fall. We have the CPO technology that we've delivered to a customer that's operating a gasoline engine on diesel for an application that's field tested. And then we also do some things we could use for industrial gas. So we actually have collaborated with a gas processing company, and we're building 2 skids to process about 40 kilowatts thermal of natural gas for an industrial application. So those 2 skids will be delivered in May. And so we're starting to take these technologies and moving them into demonstrations and gather real-world data.
Excellent. Are there any questions from the audience at this point? As always, you are more than encouraged to participate. Don't be shy, please. These are interesting topics, and feel free to share any questions you may have. So, you mentioned collaboration.
Yes.
And can you maybe say a little bit about how does collaboration with your company, Precision Combustion, come about, and how does it typically proceed?
Sure. Typically what we do is we enter into mutual non-disclosure arrangements with the people that we collaborate with. We try to keep proprietary both their information and our information. We try to understand the specification, or what we call the fit, form, and function of what they would like us to do. And we take our platform technologies and designs that we've already developed, and if we can use something we already have, that's great. It'll be a cheaper outcome. Otherwise, we'll have to do some engineering design and tweak interfaces to make sure that we've made up and do what our customer or collaborators would like to do. And so we work back and forth with stack companies, for example, and test their stacks with our fuel processor using real-world fuels. We'll provide those sometimes on test carts so they can actually test those stacks in their facility using our fuel processor, so we can get back-to-back comparisons, and we try to work forward to that, forward toward demonstrations from there. And then we also sometimes collaborate by working to obtain funding for these various projects. Usually they're funded by government agencies, and so we work together to do joint proposals and the like to try to obtain the funding to do that type of work. Yeah.
Any questions at all? Just give me a little hand sign. Excellent.
I think this is hydrogen-based cell, hydrogen gas, is it?
It makes hydrogen-containing syngas, so it'll be hydrogen and carbon monoxide. It'll also have water vapor, CO2, and then if you're using air, it'll have nitrogen.
Water vapors plus CO2.
Yes. Some of the
water vapors is H2O. Am I right?
Yes.
And carbon dioxide is CO2.
Yes.
Now it is mixed inside this. These 2 fumes means steam, and this CO2 gas is mixed inside, and then it operates.
Yes, so basically you'll have air and you'll have a hydrocarbon fuel, anything from natural gas all the way through JP8s and diesels. You'll want to mix that together in the injector in the top, and then insert that into the reformer so you can have the proper chemical reaction.
Like LPG?
You could take LPG as well, yes.
LPG. That is hydrocarbon.
A hydrocarbon, yes. We're basically hydrocarbon agnostic, and so we've reformed methane, butane, propane, ethanol, methanol, all the various liquid fuels, Jet A, JP8, and diesel. We've reformed biofuels, so we're starting to do B20, camelina oil. There's a lot of interest in the biofuel world. We're looking to get involved in biogases. We haven't done that yet, but we don't see why the technology would not be applied given you put the proper cleanup upstream, perhaps.
So this is for stationary applications or for moving applications?
The biggest benefit is for moving applications because of the size and the weight. It would certainly work for stationary applications. In fact, for some industrial and stationary applications, they care about footprint, and so then you can realize that value. This is a mesh-type substrate made of a high-temperature metal alloy. Those are typically more expensive than a ceramic monolith, so some stationary reforming processes use pellets or a ceramic monolith, which might be a cheaper route to go for large stationary. And so sometimes, like large industrial steam reforming for hydrogen plants per se, they'll use nickel-based catalysts and very large towers, and they'll have pressure swing absorption, very large banks of those to separate the hydrogen out of the gas that you make.
I see.
So you want to make sure you use this technology for something where things like size and weight and even selectivity might matter. If you want a percentage point or two higher in hydrogen content, for example, if it matters.
So what will be the size of cell? What is the maximum capacity?
Oh, yes, this is a scalable technology. So we've made reformers, like 20-watt reformers that was the size of a AA battery. 21? So for like portable power, let's say. And then it's scalable. We've made, using natural gas, you can have very high throughput. So we've made 5 megawatt thermal of throughput that was about 18 inches in diameter by about this long. For liquid fuels, you can't have that high a throughput. But we've made about a little under a megawatt thermal of throughput, a couple different reactors. One of them is something we did for a shipboard application using low sulfur diesel fuels. There's another application we made, a reformer for paint solvents, and so it's actually installed at a Ford Motor Company plant in Ontario, Canada. It's part of what's called their fume to fuels process, and they take solvents from the paint shop, and our reformer is part of a gas processing unit that reforms those solvents into a syngas that could be used in a molten carbonate stack, actually, in that particular application. So we're looking for collaborations as well, where you have waste hydrocarbon streams. You want to try to create something of value, whether it's electricity through a fuel cell or an IC engine generator, or even if going as far as doing some kind of gas to liquid chemical type reactions as well.
So here AC is produced or DC? AC alternative current or direct current? Oh,
well, it would be the direct current that would come out of a stack, per se, for DC current, and you'd have your inverter converter at the end, or if you're using a generator, it could be either one, probably.
Thank you.
Perhaps you can also continue the conversation after the interview. Are there any other questions? Okay. Well, I guess I have one last question. Just to come back to these collaborations again. Say I'm a German company here at the Hannover Messe, or any other company, and I decide to collaborate with you. Tell me how my life and my business will change as of next week.
Yes. Well, we basically start the dialogue and try to understand what the customer could tell us about what they're really looking for. In a lot of cases, because they're trying to keep their business plans confidential for competitive reasons and the like, we do it under mutual confidentiality. So that's something that we have a very standard agreement that usually we can turn that around within a day, and then we begin the dialogue. From that point, we try to understand from the customer's perspective what specification or fit, form, and function that they would need us to do, and what the roles and responsibilities are of the relationship. Tried to understand if there's intellectual property created, who owns what value coming out of that, and we try to maintain the ownership of the fuel reforming part of it, just so we don't split that up amongst other parties. That could be kind of messy going forward, trying to understand who knows what. But at the system level, we try to make everything as fair as we can, and we're looking for those win-win relationships. Typically, once we have a specification, we can turn around a quotation as to what it's going to cost and the time frame within anywhere from 1 to 3 weeks. And once we settle on a purchase order contract, we begin working together. If it's something where there's an idea that somebody wants to do something and then we have to work to obtain funding through a proposal, that takes a little longer. And so then we have to sit down and figure out how to write the proposal and who to work with. And might have to do some visits together and that type of thing to have those dialogues and interaction.
That's wonderful. Thank you.
Well, you're very welcome.
So I very much encourage you to connect to Anthony Anderson today after the interview for the rest of the week. Precision Combustion inkstand is right over there. It's a not even a minute walk.
Yes, D75, yes.
D75, that's right. For now, please join me in thanking Anthony Anderson for being here, and we'll catch up with you later on.
Great.
Thank you
very much. You're welcome. Thank you for your time.
And it is now for me to announce the next interview, which is going to happen in a couple of minutes. And the talk of the next panel, actually, is Finnish Fuel Cell Activities and Demo 2013 in Harbor Environment. And this is a panel with Rovaniemi University, Tech is Fuel Program, and VTT. Don't run away. Thank you.